the first thing I'm going to talk about is word embedding, which is in this NLP, natural language processing, but also quite important for, the data, like categorical data, or the data which you need a certain representation about it. Then word embedding become very useful. So as the when you try to looking at like a machine learning task in dealing with languages, and obviously you did have a better way to represent words. Those words typically present by so-called one-hot embedding, because it's a discrete kind of category kind of a type of data. Therefore, unlike like in computer vision, you naturally already got that very nice representation, for example, by pixel, by shape, by color, all these things have very rich representation. But seems like the words is just index, right? It's very difficult to talk about like semantics. So a typical way of doing this so-called word embedding is that can we sort of represent words in some kind of high dimensional, in this could be low dimension, could be high dimension, could be, this is a multi-dimensional real valued vector, right? And we can use it to represent, therefore, hopefully this vector captures certain semantic meaning of it. And in fact, this vector can be learned by using neural network. And also this, once you got this vector, I can using this as an input to the deep learning method, then create some consider them as kind of feature. So word2vec is one of these popular model in the early stage. And so this is the question here now is that, okay, if this is some kind of training, then I must need to have some kind of guidance, right, in order to obtain those word embedding. So think about this as, let's say, you got words like a cat, a mat, right? You have a word representation with basically this high dimensional space with a real value. And then you could put it then into a neural network. And then you need to make a prediction of something. So what would be the something you can actually predict? In this model, C4 model, called continuous backward model, is that I have multiple inputs. So suppose I got a sentence, or let's say I have got a textual data, and then I can input this let's say C number of words, and I'll try to predict what the next word would look like, and use my prediction to looking at ground truth. Therefore, I can actually compare the error. From the error, I can propagate that to really update the word embedding. So in other words, that I have this initial randomized sort of word embedding. I can put this to the W matrix. Therefore, can project this. Let's say if I have 100 dimensions of this word embedding, I project to the lower hidden layer. So in this particular model, I summation over all this C number of words together, right? And then this with a different sort of transformation. Well, after different transformation, I sort of sum them together and create this value, in the hidden layer. And using hidden layer, I using feed forward neural net fully connect to predict, for example, whether this output layer, which of words it is. I can use softmax, as output. And people actually do some sort of experiment to try to sort of map this to the low dimensional space. Let's say you have 100 dimension vector. You can using some sort of dimension reduction techniques to the 2D, and then you can actually project that into 2D space to see what happened. You find that in fact they can present certain, semantics in those space. Like for example, if you 2D, then you can minus women minus men. You can see that they will have the same value as aunt and minus uncle. So you can think that does present something, present certain semantic meaning in the word. And then once you have that, then you can make use of this word embedding to do a lot of like a downstream task. For example, you can use it for machine translation. You can do that for question and answer. You can all kind of question related things. So this is sort of another word embedding. So instead of, I have multiple sort of input, multiple words input, and and a single output. And also here is that looking at, say, I got neighborhood words, right? And then I got these words as input, and to see whether I can actually predict the words surround me. So the interesting part of this is that they're actually making use of so-called noise contrastive estimation to do the estimate. Because when you do the training of make prediction, or for example, you want to make prediction of let's say the next word, and how do you construct the kind of training lost? Because you have a positive sort of label, right? But you might have a large amount of negative labels. If you consider all of them, it's competition very expensive. How you actually do is that they have so-called negative sample. I have a sample of these words that is not belong to the next words of this, let's say this target word WT. For example, I want to predict the next word. I'm looking at the sort of this training data there for the text. And so anything like immediately after me in the text that I observed, they become positive, right? But for the negative ones, you can say anything that I have not observed, they consider as a negative ones. But the number of choice for me to construct this negative example would be extremely large, right? So what you can do is that basically you can sample it, but there's a various way to sample that. It really depends on the application. But if you construct that kind of negative sampling and really to contrast that with this sort of a positive sample, right? And therefore you can create this loss function using that as sort of a signal for you to update your model. So this is in fact, when we're talking about this contrastive learning, starting last year about the semi-supervised learning, I think this we're going to again talk about this particular technique. So this is again is some result on that. This is what we did a few years back, looking at this advertising data. So this is people did for making use of this word embedding. So in other words, you train those things and create some sort of embedding, and then can apply in all kind of tasks. And also you cannot use by the textual data, but also can use it for some, counting data. In this case, in recommendation, you can looking at to embedding like user IDs, item IDs. So to create some sort of embedding for user, hopefully that embedding to create some sort of a semantic meaning. So this sort of result from what embedding used on the recommendation. And also, this is one of these also quite strong baseline for people try to predict click-through rate and also categorical data. And people also using this for like kind of when you have embedding, you can using that to immediately apply logistic regression or apply additional like multi-layer neural network. It turns out that it will be one of these strong baseline, for people to compete with like in recommended system or try to estimate click-through rate. It's become very useful and being implemented in a lot of like big companies. And also Google in their paper and also specifies, in fact, you can also using this embedding to index video clips. They can with sort of like a loose sort of a candidate ranking and also, refine the ranking. And all it is in fact based on this, all kinds of embedding techniques. So this is a click-through rate estimation that I said that you have all this categorical data. May not necessarily be like language, but as long as it's categories, they can make use of this embedding to make it happen. So it's, initially you can have this word embedding as before, at this one hot encoding, and it can come with weight, right? And then you can use feed forward for that purpose.